In this video, I'm going to finish a question set in a previous video. In this question, the three constraints are (5x minus 2y plus 1 greater than or equal to 0), 5x minus 7y minus 9 less than or equal to 0, and 5x plus 3y minus 14 less than or equal to 0. Altogether, they form a triangular region, that is, a triangle and its interior. The circular function to be maximized or minimized is c equals x squared plus y squared plus 4x plus 2y, which is represented in the graph as the highlighted circle. By formula or computing the square, we can find that c equals r squared minus 5. Here, r is the radius of the circle. Now, as you can see, if the circle is too small, there are no points on the circle in the feasible region. When the radius is increasing, you can see that the circle starts to touch the region, and then some points in the region, still in the region, and at last, it touched the region again at a vertex, and finally leaves the region. Now let's maximize and minimize the circular function c equals x squared plus y squared plus 4x plus 2y. That is, to find the maximum value and minimum value of c. As we can see that when r is bigger, c is bigger. When r is smaller, c is smaller. Therefore, the maximum value of c is corresponding to the biggest radius, and the minimum value of c is corresponding to the smallest radius. The circle, with points still in the triangular feasible region, is the biggest when it passes through point 1, 3, which is the intersection of the lines 5x minus 2y plus 1 equals 0 and 5x plus 3y minus 14 equals 0, which is of course a vertex of the triangular region, as shown in the figure. To find the corresponding c, that is the maximum value of c, what we need to do is just to substitute 1, 3 into x, y of the circular function. Let's do it. Put 1, 3 into x, y. c equals 1 square plus 3 square plus 4 times 1 plus 2 times 3, which equals 20. The circle, with points still in the triangular feasible region, is the smallest when it touches the line. In other words, tangent to the line 5x minus 2y plus 1 equals 0, as shown in the figure. Now the center of the circle can be found by formula or computing the square as -2, -1. And the radius of the circle is c plus 5 and then taking square root. Now by tangent perpendicular to radius of circle, the distance between center and tangent is equal to the radius. The center is -2, -1, and the tangent is 5x minus 2y plus 1 equals 0. The radius is square root c plus 5. By distance between point and line, we have 5x minus 2y plus 1 over the square root of 5 square plus 2 square, positive, negative, to be determined, equals square root of c plus 5, with x replaced by -2 and y replaced by -1. By simple calculation, the numerator is -7 and the denominator is square root of 29, and we have to take the negative side because the right hand side is square root of c plus 5, which is positive, and the left hand side and right hand side should have the same sign. Therefore, c equals -96 over 29, or -3 and 9 over 29. Now we can answer the question. The maximum value of c is 20 and the minimum value of c is -3 and 9 over 29. Once again, you are encouraged to do again and think over it, okay, to make sure you really understand what happened. That's the end of this video. Thanks for watching.